Okay, so it's on the table here, so 1, yeah. Okay, so the y-intercept is 1 in this case, because when x is 0, y is 1, and the gradient is 2. If I gave you a different line, how would I get a point on this line that's definitely on this line? Any point? 0, -7 is definitely a point, yeah, on the line, because that's where it crosses the y-axis, because we know that because it's -7 here. Give me another point on the line.
-4.
Any point. -4? -4, that's one value. I need 2 coordinates for it to be a point.
1, -4.
1, -4. How did you do that? Okay, yeah. So I can create a set of points. I can find any point along this line once I have an input, because we got inputs and outputs here, x and y coordinates. If it'll cross, there's no reason why this line would stop. It will have an x, always have an x value. We just need to find its corresponding y value. We'll always have an input. So if I say when x is 0, y is -7, so I sub in. When x is 1, y is -4. When x is 2, -1. When x is 3, we get 9, take away 7 is 2. And we can create a bunch of points and put them in a table like that. I'm doing this because sometimes this question does come up in GCSE exams. How to fill in one of these tables given one of these straight lines. It's not a very difficult question, but it does come up. Okay. Let's move along. So we know that a bunch of points in a row that form a straight line, we can get an equation for that line. There is only one equation that will work for this set of points. There is no other equation that it could have the same slope, but it might have a different y-intercept, or the other way around. So all equations are unique. There is something called the general form of a line, which is a different way of arranging this. The general form looks like ax plus by is equal to d. They don't use c because this is not the y-intercept anymore. Could be, but not always. This is called the general form. In most cases, it just requires a rearrangement of this. For instance, this one would be minus 3x plus y is equal to -7, or some version of that. Just subtracting the 3x over here. And they may ask for an answer in general form. And we need to be able to switch, Annika, between normal y is equal to mx, which is called gradient intercept form, into general form, which is just a rearrangement. So I'll give you another one. If we have y is equal to 2/3 x plus 3, how do I convert this to general form? A, B, and C must be whole, A, B, and D must be whole numbers. So what would be my first step to convert? Yes, get rid of the fraction times everything by 3. So I have 3y is equal to 2x plus 9. You see the 3's here will cancel out. If I multiply everything by 3, that 3 and that 3 will cancel out. Now it's not in general form yet. I would have to put the x and the y on the same side and let it equal to the number. The slope gradient is not as easy to read from this form. You would have to convert it back into this form to read the gradient of it, which is possible, which I'll do in my next example. So let's look at another example where we have it in general form. What is the gradient of this line? And what is the y-intercept of this line? First question, I suppose, let's do the y-intercept. Is the y-intercept 7? No. It's not -7 either. It'd be 7/4, yes. So what do I need to do? Well, I need to rearrange it so it looks like this. Y is equal to something x plus or minus something. So my first stage, I'm going to subtract the 3x over here. So I have now something y equals, and then divide everything by 4. Divide everything by 4, so that 4 cancels. I get 3 over 4x plus 7 over 4. And now I can read, once I have y equals, now I can read what the gradient is. The gradient is the gradient is 3/4 minus 3/4, not the x. The x is not the gradient, just the number in front of the x. And this is the y-intercept. 7 over 4. If I was asked for the coordinate of the y-intercept, I would have to give a coordinate. What would that coordinate read? Lucas, what would the coordinate read?
It would read minus 0.
What's the x coordinate?
Minus 3 over 4.
Nah, 0. 7 over 4. Yeah, this is the gradient. That is not necessarily a coordinate. That's just saying how steep it is. It goes down 3 for every 4 it goes over. And this is the coordinate. So any point on that y-axis has an x value of 0. Yeah.
For general form, where would the gradient be?
The gradient is not, you'll have to rearrange it to get the gradient. You have to divide, it's going to be negative a over b. If you want to learn that, you don't have to. Just remember to rearrange it y equals.
Oh, so general form.
Is not very useful.
Yeah.
But it's a bit tidier because it doesn't have fractions in it.
I don't like it.
No, neither do I.
What's B and A?
B and A are just coefficients. They don't mean anything in particular. They're not. You can't say a B is something on the line. You can use them to find all points on the line, but they're not. So the gradient, for example, as I just said, is going to be minus A over B, which is not useful. It's just might as well just learn to rearrange y equals and then do it. Okay. Next thing. If I only have 2 points, can I find the equation of the line?
Yeah.
Yes.
Yeah.
Ozzy, give me a point.
3-1.
3-1. Pauline, give me a second point. 2-7. Okay, so there is a line. I can join those 2 points. I don't want to draw it though. I just want to get the equation of the line straight away without having to draw it. What is my method? Okay, you can find the gradient. How do I find the gradient?
y2 minus y.
Okay, so I label each point x, y. Say this is the first one. This is the second one. y1. So the gradient I would get first because I'm trying to fill in this. Y is mx. I need this bit and I need this bit of information. The y and x will be in the equation. So the slope is found, or gradient is found using this formula. So we do y2, which is 7, minus y1, which is 1, x2, which is 2, minus 3. So my gradient, I think, is going to be 6 in the numerator, minus 1 in the denominator, which means my gradient is minus 6, yes. So now I have this. I have a 6, hi. Oh, minus 6, sorry. I have minus 6 here. All I need is a c. How do I find where it crosses the y-axis? Do I need to draw it?
Sub in x for 0.
Yes. I can sub in x for 0, but that will still just give y and c. So that would find it, but not in this case. Hi, Priyanka.
You take a coordinate and you put in x and y.
Yes. So we have 2 coordinates we know fit the line perfectly, will work out for the line. So we put one of them in, and I will have x and y taken care of, and then I'll just be left with c to find. So I have x to be 3 and y to be 1. So I have this. So now my only unknown is c, and now I can find it. So I do 1 is equal to minus 18 plus c.
Plus
19 is c. So my equation of the line is complete. Y is minus 6x plus 19. That's the equation of Ozzie and Pauline's special line.
I'm so good at making up numbers.
You are very good, yes. Finally found your talent.
Making up numbers. 6, 4, 8, 9, 3, 9.
Okay. So I got this minus 6 first. And then I said, right, how do I find c? I put in either of these 2 points. I got these points, these are at the start of the question. So I put in 3, 1. Minus 6 times 3 is the negative 18. Bring it over here, it becomes positive 18. So 1 plus 18 is 19. That's how. And then I put it back in for the c. Okay. Not much left to do. We just are going to look at how to draw a line and then vertical and horizontal lines. How do we draw a line when we're just given the equation? Okay, yes. Yes, exactly. So there's a bunch of ways. You could rearrange it and get the gradient and get the y-intercept, which is not probably as accurate, especially if our y-intercept is not a whole number. It can be a bit tricky to draw it. So you want to create two straightforward points, and the easiest ones to find on the line are where it crosses the x and y axis. Because once you have 2 points, you can draw a line. So just find 2 points, any 2 points. You could sub in any numbers for x, and you'll get a y answer, and they will both be on the line. Doesn't matter what you put in. But we usually use 0 and 0, 0 for x and 0 for y, just because they're easy numbers to work with. So to draw it, I find what's called the x-intercept and the y-intercept. And to find the x-intercept, we let y equal 0. To find the y-intercept, we let x equal to 0. So there's 2 problems here I'm going to do. I'm going to find 2 points. Let y equal to 0 in this equation. I have 2x minus 3 times 0 is equal to 12. Now those who are quicker can probably do this without having to show the substitution, because this goes to 0. So 2x is 12, so x must be 12 divided by 2, and x is 6. What's my point? 6, 0. That's my first point. The second point then, I let x equal to 0. So I do 2 times 0 minus 3 times y is equal to 12. That goes away this time. Divide by minus 3. I get y is equal to 12 divided by minus 3, which gives an answer of negative 4. So we have 0, negative 4. So this time x is 0. So I have 2 points. Once I have 2 points, I can draw a line. I'll just do a quick sketch. 6, 0 is somewhere here. 0 minus 4 is somewhere here, let's say, and it's this line. And then I would label it as such. Okay? And the last thing are the 2 special lines, the one with no defined slope and one with a slope of 0. They are vertical and horizontal lines. So a vertical line we'll do first. The equation of a vertical line, can anyone just give me an example of the equation of a vertical line? What will it read? Yes, x is equal to something. So x is equal to 2 is an example of one. Why does that make a vertical line? Yeah, because all along this line, if it crosses the x-axis at 2, all the x values of this are 2. It does not have a slope. So if you try and solve it for a slope, it won't make any sense. It won't be undefined because it has no run. It just has a straight rise. So all lines that are vertical are x equals. So you see this in asymptotes and functions. You get x equals as all vertical lines. And then if we have a horizontal line, it's y equals, yes. So any horizontal line, you just look, see where it goes through the y-axis. So this one, let's say a 3 here. This line would be called y equals 3. So vertical lines, x equals, horizontal lines, y equals. So it's kind of counterintuitive because the x-axis is this one, which is a horizontal line, but the x-axis has a different name. What's another name for the x-axis? Y equals 0 is another name for the x-axis. And another name for the y-axis is x equals 0. Yes, that's another name for it. Okay? All right, so back to doing one of your homeworks. There's one for Thursday, one for Friday. Fridays is on this. Thursdays is on the stuff you just did. You can get back to doing that now. Hopefully now you can do the one for Friday.